Okay, let's use the four-pan balance and the zero principle to help us solve some algebraic equations. Let's start with the idea that x plus 2 is equal to 7. So we have an x, we're going to put it on this side because x, and we have a plus 2 is equal to 7. So it's equal to 1, 2, 3, 4, 5, 6, 7. So we can tell that it's equal because one side is equal to the other because the scale is balanced. All right, so how would we solve this? Well, we can see by inspection very clearly that there's positive 2 here and there's positive 2 that I could reach here. So if I made it simpler by removing 2 from both sides, notice I did it correctly mathematically because it's still balanced. What did I do? I removed 2 from both sides. So what's left on this side? Well, you recognize there that becomes 0. So x is on this side and 5 is on this side, and x in this case equals 5. All right, let's try another example. Suppose in this example we have an x on this side and we have a -3. So we have x -3. So we have x and we have a -3 on this side, and that equals and that equals 1. So x subtract 3 is equal to 1. All right, now how would we solve this? I mean, by inspection, you may be able to use your mental math skills to figure out what x is already. How would we do it algebraically? I can't remove -3 from both sides because there are no -3's here. I can't work with the 1's because there are no 1's there. What I can do, though, is whatever I do to one side, I can do to the other. I can make a zero principle to help me out. What if I took 3 and put it on this side, and 3 and put it on this side? You know I've done it right mathematically because this equation is still balanced. So what I did is I added 3 to this side and I added 3 to this side. Notice this. Do you see the zero principle? That a -3 and a +3 are opposite numbers and their total value is 0. So they can be removed from the equation like we removed them on paper, and you can tell that the equation is still balanced. What are we left with? On this side we're left with x equals 4, and x equals 4. Okay, and what happens if we end up having more than one x? Suppose we had this situation. Suppose we had 2 x's over on this side plus 2. And on this side, we had it balanced. There's 6, 7, 5, 6, 7. Not quite balanced is 8. So we know that this equation is 2x plus 2 is equal to 8. And again, you can see by inspection that I can very simply remove 2 from both sides. Remove 2, and if we remove 2, we end up having 2x on this side and 6 on that side. Let's do that. And we can tell we did it correct, mathematically correct if the equation is balanced. And indeed, it is still balanced. I do not want to know what the value of 2x is. I want to know what the value of x is. So what can I do in this situation? I can take and divide this group in half and this group in half. So let's do that. Let's divide that group in half and let's divide that group in half. And let's keep one of them. So we'll divide this in half and we'll take half of these out. And we know that 2 goes into 2 one time. What's left is 1x is equal to 3. All right, one more example. This time, let's use two x's, and then let's use a negative. So here we have two x's, and let's do two x's take away 2. 2x's take away 2 equals 2, 4, 5, not quite, 6. So here's our equation. 2x take away 2 is equal to 6. What's the first thing we would do? Well, I can't work with the negative 2's because I don't have negative 2's. And I can't work with the positives because I don't have positives on both sides. So what I can do is I can help to create the zero principle. Let's create a zero principle by adding 2 to both sides. If I added 2 to both sides, I've done it mathematically correct because the equation is still balanced, because the scale is still balanced. What I did is I added 2 here and I added 2 here. Now notice the zero principle. What happens with that? That has a total value of 0 and is no longer needed in this equation. So now we can remove it. And what it looks like on paper is we have 2x is equal to 8. Again, we do not want to know what the value of 2x is. We want to know what the value of 1x is. So we can take this side and take half of it, and take this side and take half of it. 2 goes into the 2 once. We have x left, and 2 goes into the 8 4 times. So let's take half of this, and let's take half of this, and remove it, and we see that x is equal to 4. Okay, so now let's take a look at what happens when we have x on both sides of the equation. On this side, we have 3x plus 2. 3 x's and a 2. And on this side, we have 2 x's plus a 5. All right, so how would we solve this? Well, in order to make it less complicated, the first thing I see I can do is I can get rid of some of the x's. So I know that I can remove 2x from both sides, and that would help me to make this thing simpler. I know on this side, if I remove 2 x's, 1, 2, and 2 on this side, I know I've done it mathematically correct because the scale is still balanced. 3x removing 2x leaves 1x plus 2 on this side, and that equals 5 on this side. Now we're back to the equation the way we had it before. I wish to remove the 2x to make it simpler. I can remove the 2x from both sides, and that looks like this. Removing 2, and I get 1x, because that becomes a zero principle. 1x equals 3. And you can see that 1x equals 3. Okay, what happens if we do it with negatives involved? So let's go back to that same situation that we had, and we'll put 3x on this side here. And what if we had 3x and we had 3x take away 2 is equal to 2x and 2x plus 1. All right, let's try that one. So on this side we have 3x, subtract 2 is equal to 2x plus 1. Again, and the first thing that I see is that I have x's on both sides, and if I could remove them, that would make things a little bit easier. So we will. Let's remove x on this side. 2 of them, remove 2 from this side, and remove 2 from this side. What does that look like on paper? On paper we say we remove 2x and we remove 2x. So we've simplified this. 3x subtract 2x is 1x, take away 2 is equal to, and that becomes 0, is equal to 1. Now to simplify it further, I have negative 2 on this side, but I do not have negative 2's to work with here. I have a positive 1 here, and I have no positives to work with there. So how would I solve this? Well, let's use the zero principle to help us solve this. We know whatever we do to one side, we have to do to the other. So if I add 2 to both sides, I've done it correctly because the scale is still balanced. What I've done is I've added 2 to both sides, but notice what happens here. Notice what happens with this 2 and that 2. There's your -2, there's +2. And again, those are opposite numbers, and opposite numbers have a net value of 0. So these really are not important to the equation, and you can tell it didn't make a difference on the scale. The scale is still balanced. So I have that 1x is equal to 3.